So in this video I'm going to give you the recipe for how to know if a point is a local maximum or a local minimum. Or in other words, I'm going to give you a trick to know if the second order term of the Taylor expansion is always positive or always negative, regardless of the values of delta x and delta y. And the way to do it is as follows. Starting from the expression for the second order correction term in the Taylor expression, so I have written it using the notation fxx instead of using partial f dx squared. Yeah, I have written it using the subscript x twice. So starting from this, which is the Taylor expression, you can do some basic algebra. You can do some basic algebra, and you can arrive at this alternative expression. But this alternative expression is really good because in this expression, all the appearances of delta x and delta y are inside squares, which means that changing delta x and delta y, no matter how much we change it, we know that this is always going to be positive and this is always going to be positive. And therefore, to check if the sign of the term, the second order term in the Taylor expansion, can change sign or not, we can just look at this term here. If this term is positive, then the sign of delta 2f is always positive regardless of delta x and delta y. While if this term here is negative, then it means that I can always find some combination of delta x and delta y such that in some combinations the second order term is positive and in some other combinations it's negative. In other words, if this term is negative, then this second order term in Taylor expansion changes sign. Okay? And that's how in practice we classify the stationary points. Okay? So I can summarize everything in this golden box. Okay? And this golden box is something that I give you in the exams, in the list of equations. So basically, this is how it works. To find the stationary points, to find them, we need to check that the first order term in the Taylor expansion equals 0. Okay, and this is in all directions. And this is equivalent to finding that the two first order partial derivatives must be equal to 0 simultaneously, both of them. So that's the way to find them. And then in order to classify them, we can do the following. If this term here is negative, then we know that the term delta 2 changes sign. Okay, so therefore we know that this is a saddle point. On the other hand, if this term is positive, then we know that the second order correction term delta 2 in the Taylor expansion never changes sign. It always has the same sign. And therefore we know that this is either a maximum or a minimum. And the way to tell if it's a maximum or a minimum is very easy. If f of xx and fyy are positive, then this is a minimum. And if fxx and fyy are negative, then this is a maximum. Please note that if this is true, then it's impossible for one of these to be positive and the other to be negative. Okay, because then this would not be true, because this would be a negative number, so therefore we would be in this case. Okay, so therefore once you check this condition here, then it's enough for you to check fxx positive, and you know that fyy will be also positive. But anyway, this is not extra work, because in order to find the sign of this, you have had to calculate all the second order partial derivatives. Okay, so you have that calculation anyway. Finally, there is a third case. If this term here, fxx fyy minus fxy squared, equals 0, then we are not sure. This is undetermined. And we would have to look at higher order terms in the Taylor expansion. Please don't worry about this third situation. I will never put this situation in an exam. And if this happens in an exam or in a problem, you get that this is equal to 0, then you just say this is undetermined. I won't ask you to look at higher order terms in the Taylor expansion, because I think that's out of the scope of this first year module. Okay? So this is it. With this, you have everything you need to remember, or you need to know, or you need to understand in order to find and classify the stationary points of a function f of xy. In the next video, I will do an example. Thank you very much for watching. See you in the next video.